So, doing a presentation on responsible AI using SciPy. And my name is Andrea Hobby, as he mentioned. About me, first year doctoral student, which you mentioned. Really interested in developing responsible AI solutions that'll enhance patient safety and healthcare quality. So that's what I'm looking forward to in my program. Previously, I worked at HRSA in the federal government as a data scientist, working on more like data science strategy and developing some models for like healthcare operations with community health centers. And also, I worked as a data scientist at Central Federal Services, where I worked on a whole bunch of different healthcare and non-healthcare projects and for state and federal governments, which was a great experience. You can connect with me on GitHub or LinkedIn or a newsletter. So, and here's a QR code or the GitHub link for the slides if you are interested. Yes, I have about 15 years experience working in the healthcare industry, but less experience, maybe like 4 years in data science. So ask me anything about the healthcare industry, and I'm still growing as a data scientist. So hopefully everybody has a QR code. Go to the next slide. Here's what we'll cover today. I'll do an overview of AI, responsible AI, and its importance, and I'll review some of the principles of responsible AI. I'll do a brief SciPy overview, and 3 tutorials. Hopefully we get through the first 2, and we'll see about the third one, and then we'll open the floor for questions. And introduction. What is AI? So this will be geared towards people who are just new to AI. So the goal of AI is basically to create systems that can interact with their surroundings. These systems are referred to as intelligent agents. I created a little graphic here with a little intelligent agent that's collecting information or gathering information from its environment and using all its senses. And it's taking in this information and processing it and deciding what to do. And this image is deciding to move this car on the road. But basically, the goal is to gather information from the surroundings and decide what to do and act on it. An AI system is a tool that brings AI to life. It's a computer program designed to do specific jobs or solve certain problems using AI algorithms. For example, AI systems can be used with photos, help with tasks like recognizing faces in photos, translating languages, and even driving cars, which I think most people are probably familiar with by now. I don't know, hopefully everybody can see this. I was hoping this would come up. Okay. Example of an AI system maybe that's in a hospital. So we have the data sources. So if you're in a hospital for AI system, you might have data from the pharmacy, data from the lab, maybe you have data from billing, you have like text data and the electronic health records. There's all sorts of data within a hospital. And then maybe if you have an AI system in a hospital, you have like a data processing algorithm to process the data into the format you need to be used in the machine learning model. And then if you're in a hospital, you definitely would have like a user interface for like the clinician or nurse to interact with it, because most clinicians and nurses don't know anything about AI or models or machine learning or anything. So they just want to interact with the interface. They don't really care what happens on the back end. So you definitely would have a user interface. And likely it'll be integrated with other systems, like hospital, pharmacy, building, or the building departments. I've worked on some projects where I worked with the state. I guess it was like a big project for a state government, and they're getting data from like laboratories around the state and putting the data into like a central database. And then they had like a user interface to predict, I guess, the lab testing turnaround for these different lab tests during COVID. So that's an example, and some of that information was transmitted back to the different state health departments or county health departments, so it can be integrated with other systems. So what is responsible AI? Responsible AI ensures ethical, fair, and transparent use of AI. Responsible AI is an approach to developing and deploying using AI systems that align with ethical principles and societal values. Why is responsible AI important? It's important for keeping people impacted by AI safe and those who created the AI systems accountable. I have some the back of the slides, I have some references to different studies that people might find interesting related to how AI is used in the healthcare system. So check that out if you're interested. But some examples are improving the accuracy and speed of breast cancer diagnosis, reduce bias in machine learning models for heart disease. Those are just a couple of examples of how AI is used in the healthcare industry, and also they kind of show why responsible AI is important. Here's a real world example of a AI model, Optum, which was a part of United Health, developed a risk prediction algorithm, and they use in their algorithm a variable for healthcare costs, which they thought would be a good proxy for healthcare, the need for healthcare services. But there's a study done by some scientists at UC Berkeley in 2019. They found there was actually error in this algorithm. By them using the variable healthcare costs, they were systematically being biased against Black patients who overall had lower healthcare costs because they had a harder time accessing care. So it basically looked in the model that only certain groups need healthcare resources, and maybe Black people didn't need healthcare resources, which they needed healthcare resources, but it wasn't showing up in the model. So basically, fewer Black patients were flagged for care. But basically, the scientists went in, I think from UC Berkeley, and they basically took out the variable healthcare costs. They looked for other variables within the healthcare data set. And by finding other variables where they were a better proxy for healthcare need, they were able to revise the algorithm and reduce the bias in the model by 84%. And I have a site there so you can go learn more about it. Principles of responsible AI. General principles of responsible AI are fairness, privacy and security, safety, accountability, transparency, and explainability. Fairness, the fairness principle is basically AI systems shouldn't discriminate against protected classes, whether it's gender, race, ethnicity, religion, or other personal characteristics. I've seen some examples of this. In the news, every now and then in the news, you'll hear a story about, God, I heard this one, it was somewhere in California. It was within the banking and finance, where they're systematically discriminating against a certain ethnicity in California and denying their loan applications. And they end up with a big lawsuit. So fairness is really important because let's say if you have a company and your model is discriminating against a protected class, and you don't realize it, you could be in trouble with a big lawsuit. So that's why fairness is important. And also it's good to help protect people. And privacy and security, basically for privacy and security is about handling personal and sensitive data in ways that respect individual rights, maintain confidentiality, and protect against unauthorized access or misuse. Privacy and security is really important for your AI models. Let's say you have an AI system in a hospital and your data source gets hacked by some hacker and they alter the data in your data source, and you have a model running using this data to predict whether or not someone should get a medication for their heart disease. If the data is altered in the data source because of some hacker, then your output is not going to be good, and then you're going to end up hurting somebody or killing them because your AI system or your data source for your AI system got hacked, or a bad actor got involved with it and altered the data. So privacy and security is really important. Also, there's lots of laws around privacy and security, so it's really good to try to follow those data privacy laws because it will help protect your models too. Safety, the safety principle is also important. You want AI systems to operate as intended without causing harm to people or property, or environments. So AI safety, like for healthcare, is especially important because, well, you're making like life or death decisions, so you want your AI models to not, let's say you're trying to recommend whether or not someone gets a surgery, and you don't want people to get recommended for surgery that don't need surgery, or vice versa. So AI safety is really important, especially in the healthcare industry, just because definitely life or death decisions in the healthcare industry. And accountability is another principle. Accountability basically focuses on the process by which people, institutions that design and develop and implement and use AI systems are held responsible for those results and operations of these systems. This involves maintaining human oversight, guaranteeing decision traceability, adhering to legal requirements, putting in place explicit procedures for observation error or bias correction and safety protection. And I have like a little graphic here. Accountability is really important. So if you have like an AI system in your hospital or a clinic, or you have some other healthcare setting where you have AI system, it's okay to have your AI system, but you definitely want to have a human in the loop to review output of that system and just like to monitor its performance, just to make sure everything is behaving and operating as intended. And then after that, you can make a final decision. But it's really important to have accountability by a human and not just leave it to the AI system being like, oh, it's a black box, I can't figure out what's happening. Oh my God. Especially in healthcare. And then also I've worked on some finance projects when I worked in consulting, and they definitely were very concerned about accountability, just because people are very serious about their money, so they want traceability in their AI models. So if it recommends someone gets audited, you want to be able to go back to the model and pinpoint which variable was used to decide who was audited and why. And let's see. We have transparency and explainability. Transparency is being clear and transparent about how AI systems are developed and how they operate, what data they use, and how decisions are made. This kind of goes back to the example I was talking about when I worked on it briefly on a finance project when I was working in consulting. It's like my one non-healthcare experience in the last many years. But they're really important about transparency, because they could always get audited by the government, and they wanted to make sure any models they use were explainable and transparent, so that if someone in the government came to audit them, they could show the model, the variables, and everything was traceable, so they basically wouldn't get in trouble. But the same could be said for healthcare. You definitely want that. Like if a patient comes to you and they're like, why were you recommending me this drug when it caused all these side effects, and use the AI system to do that, you definitely would like to be transparent and explainable. And then explainability is an AI system's ability to produce coherent and human readable explanations for its decision and outputs. It's really fast. Okay. And then best practices for implementing responsible AI. I think it's really important to have like a diverse data set. Like if you're working in a diverse healthcare system, and you want to set up like some AI model, you want to make sure your data reflects the people that are in your healthcare system. It should only reflect a portion of the healthcare system, of the people representing your healthcare system. You definitely want to have human review, just because it's good to have accountability by a human when you're developing an AI system. Secure your data, because privacy laws, and it's the right thing to do, because your model will perform better if your data is secure, and you'll just be in better shape. And you really want transparent decision making for your models, if at all possible, just so you can be accountable. And if something breaks in the model, you want to be able to go back and fix it. So transparency is really important too. And there's other responsible AI tools. There's Google's What If tool. I've never used that one before, but that's a responsible AI tool that people often use. Maybe like if you're working in a business. Model cards, I've used model cards in some of my roles. Microsoft has an Azure Responsible AI dashboard, which I've used once. It was a while ago. And then Python has some responsible AI libraries. There's FairLearn, responsible AI, CHAP, and there's other responsible AI Python libraries. And then also it's really important to monitor your AI systems for abnormal or incorrect output. Like I know in one of my roles where I was working in this large AI system with a team of, how many people on the team? There was a lot of people on the team, but I was building maybe like 3 or 4 of the models, but we had to set up a system to monitor for model drift. Basically, your model, the change, basically year over year, the model performance could change. And you want to be like monitor for that because you want to get the output that you need to take whatever actions you need or wherever you're working or studying or whatever project you're working on. So just check for model drift over time, and also checking for data drift. If your data drift is changing over time, you might need to like rebuild your models. But these are some best practices for responsible AI. And SciPy overview. So we will go to tutorial in a second. Basically, SciPy is an open source Python library for scientific computing. Here are some SciPy modules that you can use for responsible AI. I think mine mostly focus on the SciPy stats one, but we will tutorials in a second. And then tutorials, that's the link to the tutorials. But you probably can get through it through the GitHub if you have opened your GitHub already. But we will do this. Everybody can see that. Here's the first tutorial, which you can see. So that's what the GitHub looks like. So the notebooks are in here if you haven't seen them, and if you want to pull the data, there's data in here, base data.csv, and you can see the slides there too. But so you know, and there's a short README. That's a lot. All right, so this first tutorial, basically we'll kind of look at bias detection with using SciPy, mainly the SciPy stats module. Basically, it's used for statistical analysis to detect and quantify bias in data sets and model outputs. So that's what the SciPy stats module is. And if you don't have these libraries installed, you might want to install them if you're running it on your computer. So I've already had these installed, so I will not run this, but here we go. Let me start this and clear my output. So let's see it. All right. So for this first one, I import the NumPy library and the OS library, just because that's how I connect it to the data. Pandas to manipulate the data. Seaborn, I think I have a plot in here somewhere. I used to have a plot. Well, I'm not sure if it's in here. Matplotlib. We use the stats module here. Didn't really use optimize one here, but it's in there. And breast cancer data. And here's some other train test split to split the data set into the train and test data set, and end up using the random forest classifier for the model for this example, and also accuracy score. So basically I set the change it to the current directory. That's my path to the data in my computer. And I read in the data sets. I should run this because over here. And then some info about the variables in a data set. So we have ID, we have age, female. The female is a binary variable, it's 1 and 0. So female is 1 and male is 0. Actually, did I go over in this data set? I think I totally forgot to go over this data set. But basically this data set that I'm using is, I have a description here, but what's in here? Basically, it's a data set from the National Health and Nutrition Examination Survey. It's a data set on chronic kidney disease. Basically, chronic kidney disease is a disease that impacts about 37 million people in the United States. And basically, early detection and diagnosis are really important to prevent the progression of kidney disease to kidney failure. So I use this data set as an example. Just so you have some more background information about it. And also I used to work at Georgetown University Transplant Center, so there was lots of patients that had chronic kidney disease that ended up coming in for transplant after the kidney failed. So that's why I use that as an example. Okay, so back to library, Seaborn, and then machine learning. Okay. And this is different racial groups that whether the data set, the education, unmarried. We have income variable, care source, insured. We have weight, height, BMI. These I didn't end up using all these variables in the model. We'll see further down. SBP means systolic blood pressure, and DBP means diastolic blood pressure. HDL is basically high cholesterol. LDL's I can't remember what LDL means right now, but these are basically for cholesterol. And then this is total cholesterol. I get dyslipidemia. Can't remember what PBD is right now. Activity, basically the level of activity of the person who responds to the survey, or vision, smoker, whether they have hypertension, whether they have family history of hypertension, whether they have diabetes, or they have family history of diabetes, where they have a stroke. CVD is cardiovascular disease, which is basically heart disease. CVD is basically if they have a history of heart disease in their family. And then I think CHF is congestive heart failure, I believe. Then anemia is basically a blood disorder. And then CKD is chronic kidney disease. So that's the target variable for all these examples and all these tutorials. It's basically binary 1, 0, CKD. If it's 1, you have chronic kidney disease, and 0, you don't have chronic kidney disease. And next. And here's the distribution of some of the variables. We have ID, which I'm pretty sure I end up dropping because ID is pretty non-informative. We're building a machine learning model. We have age range, which is minimum is 20, max is like 85, I believe, for this data set. And then you can see it's for the females, and then education level, whether they're married, income is a wide range. Let's see, insured. I think it's whether or not they're injured, so I think it's like 1 or 0. Yes, so basically all to summary of some of the variables here. Let's see, next one. And then here you can see that there's a class imbalance for the target variable. So CKD, what I said was 1, that means that they have chronic kidney disease. Only 464 participants or responders to the survey have chronic kidney disease, and over 5,536 do not have chronic kidney disease, which is important. I don't think I did it for this example, but there's like you have a class imbalance in the model. You might want to resample your data set just so you undersample the majority class, which is here would be those that don't have chronic kidney disease, but I don't think I did it for this example, but could do that in a different tutorial. And here I just dropped some of the variables which I thought were not informative. Like ID variable, you don't need that in a machine learning model because an ID number is not going to help predict if someone gets chronic kidney disease or not. Weight, height, I feel like weight was redundant because I think there's a BMI variable. Height, I removed it because there's a BMI variable. And obese and waist, I feel like those are all related to the BMI variables. I just dropped them from the data set because that's redundant. So, and then here, yeah, so I kind of drew up a nice sketch. And then we have the population bins here. So I just kind of reorganized the age data. So it's 18 to 34, 35 to 49, 35 or 50 to 64, and 65 and older. And I basically kind of bin the age group data together. And more bins, and then I guess create some bins for the BMI. So if it's, I guess, 0 to 25, it's normal, which it really should be like 19 to 25. But, and then overweight is like 25 to 30, and then 30 to 100 is obese for BMI. And then here I just kind of worked on formatting some of the features again, just so that it could be read by the machine learning model. So here and here. So basically I took some of the categorical variables and just made them into like binary variables. Like there's a race group here. That was the overall variable, so I kind of split it out. So a part of that race group variable was Black and Hispanic, other, white. So I just kind of took that one variable and made it into several different variables, so it can be read by the machine learning model. Let's see what's next. I also did it for care source as well. So care source used to be one variable, now there's care source. They have their health insurance from like HMO, or maybe they're getting their care sources from a clinic, or maybe they don't have a place where they're getting care. So that's its own separate variable now, or other. Yeah. This one is converting some variables to floats, so it can be read by the machine learning model. And same here, converting it some of the variables to floats. And then you can see some of the new variables that were created. Yes, for the race group and the care source that I mentioned before, and also the age group float. So it can be read by a model, and the BMI group floats that can be read by the machine learning model. And we'll drop some variables since we have age and BMI here. We can drop this since we don't really need these variables anymore since we created new variables for these. Next. Okay. So basically the data should be in the format now to be able to be used by the model. We're going to split the data. So basically X is all the features or variables or inputs for the data for the machine learning model, and then Y is the target or output for the machine learning model. And let's see what else. And here we're going to split the train and test. Here we have a random forest model, kind of like a very big decision tree that we'll put here. and model using X train, which you see here, and Y train. So this is about, I think, test size is 0.3, so it's probably 70% of the data was used to train this model. And then some predictions of the accuracy based on this random forest classifier that we just built. And the accuracy is 0.94. And why is this not working? It's working. I can type something. Okay, well, this was working previously. Of course, this stopped working.
It's the comment.
Yeah, line 15.
If a result is significant, it needs to be commented out.
Oh, this, yeah.
I think it's just a parentheses to close out the print function.
Accuracy by group. So basically, since I used the female variable for this example, 1 is female and 0 is male. So the female group for basically this model is slightly less accurate than the male model for predicting CKD or chronic kidney disease. And let's see. And then here we have add some noise to the model. And basically you want to make sure if you add some noise to the model that it performs roughly similarly, which it does. So model seems to be predicting what it should be. And transparency and feature importance. And based on the model that we built, this is, I guess, the top 10 most important features for the model. So usually SBP is systolic blood pressure, and then total cholesterol, diastolic blood pressure, which are all very strong predictors of kidney disease for this model, chronic kidney disease. LDL, HDL, which are both cholesterols. Age group is a predictor, and not as strong as blood pressure, and then BMI, also the activity, how active you are, and hypertension and diabetes. So this is an example of future importance, and it's like a good example of how to show, like if you're working like with the data set or building a model, like how to be more transparent with basically what's influencing the output of your model. So that is that example right here. Let's see.
So I have a question.
Yes, sir.
In the beginning, you talked about the imbalanced nature of the data set, and I think it was like 92.5%. Like it would have been 92.5% accurate if it just said no one has chronic kidney disease. So like would accounting for like that imbalanced nature in the training, do you think that would improve the accuracy of the model?
I'm like, it might improve it or it could worsen it if I like went back in and actually balanced it so that the targets so they weren't so unbalanced. So, but it could go either way, to be honest. Most likely, I'm assuming the accuracy could go down just because if you have a less of the majority class, it would have to be more tuned into the small group of people that have chronic kidney disease. But I didn't do that for this example, but that's something to do. I think I've done that before, but I just didn't do it today.
The other thing I sometimes do when it's super imbalanced is I won't use an accuracy, I use precision and recall.
Yeah.
And then you don't have to resample it,
Yeah.
and it'll give you like a more clear insight into the imbalance class problem.
Any other questions?
Super interesting so far.
That's tutorial one.
Excuse me,
Yes.
can you talk a little bit about the robustness test? So what you did is you added a bunch of zeros into the data set? Is that what you're doing there to see if the noise had an impact on your result?
Yeah, added a bunch of like random numbers and basically
Okay.
decided and basically see if it would still perform the same, and it did. But I'm like, definitely if we went back and resampled the data the correct way, well, not correct, but I know it's a personal decision if you want to resample data. But it's good to resample the data to make sure this is more balanced. That answer might have the robustness test might have a different answer.
Okay.
After you do all that, so
You add the random data and then you resample it based on that new data set, and then you move forward from there. Is that what you're saying?
I guess I'm saying you should resample the data like up here. So when you get to the robustness test, it will likely have a different output.
Okay.
Yeah, it's like you resample before you train. So when you train, you sample on data that is more balanced, and then accuracy will be more reflective of model performance.
Can I also ask a question?
Mhm.
So on the section where you did your chi-square testing, I just didn't quite follow exactly why you're doing the chi-square. Is that a hypothesis test to see if your variables are significant predictors, or what is that? What are you,
Yeah, I think
what's the
I
hypothesis you're
think
testing?
I think I kind of flew by on that. Sorry. Basically, I did it to see if there's like a difference between like what was in the data, and then what I expected right here. See what's in the data and what you expect that there's no connection between your variables. So I mainly for the variable for female versus male to see if basically if there's like a real difference between what is like in data set and what was predicted. Basically, this got cut off here, but basically, if basically the results is significant, it means that there's a gap between what you observed and what you expected, and it didn't just happen like by luck. So, but yeah, there's the chi-square test is like a good tool to use for, I guess, bias detection and your features that are used in the model.
And like, if you have bias coming from one of your predictors, what would that look like if you did a chi-square test? Does that mean that there's a low correlation or a high correlation, or?
You would likely see like there's a big like a statistical significance if there's like a bias in your like one of your features.
Okay,
You're
gotcha.
comparing it with like another feature. Let's see. Well, let's see this one. This one, it's the same data set basically. We're more focused on sensitivity analysis. Exists if you don't have the libraries. Here you can import libraries. Basically, this is the same code that I walked through before, so I will walk you through this again. Here we train a model with a random forest classifier. Again, and then calculate the mean absolute error. And then, or I guess for this one, since it's like a healthcare example, you want the mean absolute error to be close to 0, just because you want to minimize the amount of error that's in when you're using building models that are healthcare related. So as close to 0 as 0.06, so that's good.
To the same features and the same
Yes.
response as the earlier notebook?
Yes.
Okay.
And let's see. Feature names. Here, just the probability of being in class 1, basically the probability that that the person has chronic kidney disease. And let's see this one. This kind of formats, not formats, but it's formats the model. So this is transpose here, and then this is about probability of being in the positive class, which is basically positive classes if they are have chronic disease. And then find input distribution. And basically here we're running a sensitivity analysis using SciPy. So basically with this one, this is how we interpret it. So basically it's high sensitivity, which is this ST. So this column is high sensitivity. So basically the hypertension variable is the most sensitive variable in the data set. Which basically means the small error in this hypertension variable could cause a large swing, whether or not a patient's likely to get have CKD, chronic kidney disease. So there's that here. And then also there's a gap between S1 and ST. So basically this is this first order sensitivity analysis versus total sensitivity. Not sure which one has the largest gap, but whichever variable has the largest gap indicates there's some sort of like interaction effect. So let's see, like here age group is probably likely an interaction effect, which makes sense. So like you're more likely to have chronic kidney disease the older you are. It's a disease that usually in older people, so that makes sense. There would be like a large, I think, interaction effect. And here's blood pressure. That makes sense. There's a big gap between the sensitivity, first order sensitivity, and the total sensitivity. Since that's if you have high blood pressure, you're definitely a huge risk of chronic kidney disease. Whereas if you have low blood pressure, not really at risk at all. So that makes sense. That there's a large gap between those, but that's how to interpret that. And then
So can I ask a question about that? So
Yeah.
it's common practice sometimes to take a look at your features and skinny down the list because you want it to be a little bit more efficient.
Mhm.
Would you use this kind of a result to say, well, I may not wanna do that because I notice a difference between gender, I notice a difference between ethnicity. You see what I'm saying? If you see a big gap
yeah.
and you see that relationship, you'd be nervous about bias, so maybe you wouldn't take that feature out, you know what I'm saying, or take it out.
I would personally would leave the feature in and probably figure out like an additional analysis to do with with the data.
I got you, so if there is a big gap, you leave it in versus take it out.
Yeah.
I got you.
Like if it was like this down here, like here source, like this is like I would take this out. Like these on the lower end, I would definitely wouldn't have a problem dropping some of these.
I got you.
Or if their like numbers are really close together, yeah, probably those I would drop out. But if there's a big interaction between, yeah, I wouldn't drop it.
Take them out, I got you, thank you.
Let's see. Yes, here. So like here, low indices. So basically inputs that barely influence the model, candidates for being deprioritized. So I think this is a good candidate for being deprioritized and not include the model like care source, at least this variable. There's probably some other ones like here. I feel like this other care source it's probably, I'm assuming the group is so small that it doesn't really make a difference, so you probably don't have to include it in the model, but I also depends, I feel like, what the purpose of your model is. Maybe you have a model that's really looking into care sources and maybe you want to keep it still, but I guess for this model today, I would probably drop it out, but let's see. And then here is basically a visualization of the results of sensitivity, which one has the most sensitivity, which is hypertension, and then the age group variable, and then the blood pressure variable, and also LDL, which I don't know why I'm going blank on what LDL means today, but it's cholesterol and diabetes, and cardiovascular disease are the top sensitivity. It's like basically top sensitive variables, which have a huge influence over whether or not a patient is likely to have chronic kidney disease. Is that any more questions on this one?
I see one question in the front row.
Huh?
I see one question over here.
Oh yeah.
So if I were trying to predict something such as, for example, lung cancer, I know that you cited your individual access data for this project, but is there any like good source to access like data from patients?
For like lung cancer, I'm sure there's like some university has like a repository of lung cancer data. I can't think of it off the top of my head. And then I'm like, the government used to, but they might still, but I don't know. But yeah, actually I can think about that and share the information with you after. So, but usually the government was my first source, but I'm not sure right now. So I'll think about that. And the last tutorial, which not really want to go through because it's a little. I'll upload this one later. Basically, the last tutorial was supposed to be basically focused on having transparent models, which uses decision tree as an example of explainable model. And it compares it to logistic regression, but I'll upload this one later. And then it uses Shapley values, which is basically like a SHAP library in Python, which is basically used to see which variables move the prediction away from the average of the data set the most. And this one was being weird this morning, so I will upload this one after. So let's see. Yeah, I will upload this one later. But any other questions?
Do you have an example of using Shapley? I've heard of it but never implemented it. So it's pretty.
Yeah, I used it on a previous project for, I think we're predicting like the cost of breast cancer. I think it's when I worked in consulting and we used it. We had 3 different models. I think we had like a random forest model, decision tree, and some other model. I can't remember now. And then we used Shapley values on all of them just to see which variable basically explained why the model is performing the way it is the most. Here was, I didn't run this whole thing, but example, I have it here. But basically it kind of looks like this, but not, and it has like a list of variables that are most likely to explain like why the model is performing or behaving the way it is. I guess for the breast cancer one that I worked on before, like what was most likely to predict the cost was like health insurance, which is obvious, and like some other variables which I can't remember right now. But it had like a list of like the top variables that were most likely to influence or explain why the model is performing the way it is.
does it speak to like significance or like magnitude?
Good question. Maybe like magnitude. Other questions? Q&A. So.
I've got a question. So are you familiar, have you done any work with healthcare synthetics, you know, in terms of like being able to generate like a very broad distribution of data and then using that to kind of, you know, look for where biases might be showing up and
I haven't worked with. I don't think I've worked with any healthcare synthetic data. I know I've worked on projects where they wanted to, but then like they always got caught up in trying to buy the data, and then it was like a whole thing. And then I was ready to move on to next projects.
so how, like, what are some ways that you might bootstrap that problem then?
I know there's ways you can like. I've done it more myself. There's like some websites where you can generate your own synthetic data, and then I just kind of put in like what I was looking for in the data set, like the distribution of variables, and like I've done that before, and then like downloaded it before and created my own like fake synthetic data set. But I'm not sure how high quality that was.
Sure,
But
yeah. Cool, thanks.
I have references here. Yes, if you have any other questions, then we can go get some coffee.
Good.
More questions? I don't have anything else right now. So.
Thank you.
Oh, no problem.